the world is digitalized today, there is a sense of intelligence. There is a sense of communication in each every traditional device that makes our lives so easy and so fast. All these technological advancements are taken forward by software, which is a bunch of programs that are meant to solve a problem. And every program is built upon a logic or solution, which is called as an algorithm. The term algorithm is named after the clever man from Baghdad, Abu Jafar Muhammad ibn Musa al-Khwarizmi. He was the first person to introduce algorithms to the world, which were mechanical, precise, and unequivocal. So what is an algorithm? A standard textbook definition would be: an algorithm is a well-defined step-by-step solution or a series of instructions to solve a problem. An algorithm can be the method to find the least common multiple of two numbers, or the recipe to cook lumpiang Shanghai. In computer science, it refers to a special method for a computer program to accomplish a task. You see, computer basically does a lot of math, which means it has a lot of problems to solve. That's exactly why algorithms form the heart of computer science. A computer algorithm is a computational procedure that takes in a set of finite input and transforms it into output by applying some math and logic. Algorithm design isn't easy, but it's not impossible either. People who design algorithms don't sit around looking for problems to solve. They are usually already involved in projects when a problem arises that requires a solution. Now we will describe the four stages of algorithm analysis and design. The first is design. The first stage is to identify the problem and thoroughly understand it. This is where it's important to consult with everybody who has an interest in the problem. Speak with them and see how they see the problem and what they need out of the solution so their part of the project or program can progress. After you obtain the input, break out the problem into stages and calculate what happens at each step so the next step can occur. All of this is elementary, and you probably did this from the first computer science class you ever took, but the same basic rules apply. This is also the point where you are going to flowchart or use pseudocode to work out the specific problems of solving the flow of operations within the code. The second stage is to analyze. Once you have the basic framework of the algorithm, it's time to start analyzing how efficient the code is in solving the problem. Algorithm design is fluid and subject to individual plans. This is a step that some programmers like to attack after they have coded the algorithm and run it through the compiler. Others prefer to examine it prior to writing the code and analyze results based on their expectation from the design stage. Either way, what you are doing is looking for the efficiency of the algorithm. Algorithms are measured in time and space for their efficiency. Look at the algorithm you are designing and see how it works with different size data structures and what kind of time it takes to work through those structures. The problem here is deciding when the algorithm has reached maximum efficiency for the project and produces acceptable results.
Third stage is implement. Writing and coding the algorithm is the next step in the process. If you are the one writing the algorithm, then you need to write it in the coding language you understand the best. In order for you to know how to write the algorithm efficiently, you have to know exactly what each line of the code is going to accomplish when the program is executed. Write that code to execute quickly but can also handle the input data that it will receive. Last stage is experiment. Once the algorithm is designed and coded, go back and experiment with different variables in the algorithm. Try and enter data that will make it fail, or try and rewrite the code to work it out most efficiently. Experimentation in algorithmic design is really just another step of the analyzing of the algorithm. Keep attacking the efficiency aspect until it executes as much data as necessary in the smallest amount of time. When you find flaws in what you have written or ways to write the code better, then go back to the design step and redesign the algorithm. The design analysis of algorithm is a circular process. An experiment on an existing algorithm might lead to a new design, or a recoding of an algorithm might lead to a more efficient execution. Wherever you find yourself, keep working towards the goal of efficiency of the algorithm.
The subject field of algorithms has grown so deep and wide that the theories and the basics that are laid down will help us attack any computational problem. There are so many efficient algorithms that are already published, like binary search, bubble sort, insertion sort, merge sort, weakly sort, Euclid's algorithm to find the GCM, Prim's algorithm to find the shortest path in the graph, and others. While there are many types of algorithm, the most fundamental types of algorithm are divide and conquer algorithm, dynamic program algorithm, brute force algorithm, and lastly, greedy algorithm. First one is divide and conquer algorithm. Divide and conquer consists of two parts. First of all, it divides the problem into small subproblems and then combine the result of each subproblem to get the final result. Just like you first segregate the coins of different denominations into different buckets and then count the number of coins in each bucket to find how many coins of individual denominations are there. Second type is dynamic programming algorithm. This type is the same as divide and conquer, but it divides the problem into subproblems such that the results are usable for other subproblems. Third is brute force algorithm. This type is like trial and error. You simply try all the possibilities until a satisfactory solution is found. This type of algorithm is also used to find the best solution as it checks all the possible solutions. And also, it is used for finding a satisfactory solution. It simply stops as soon as a solution to the problem.
Last is greedy algorithm. This type follows a problem-solving heuristic to reach the next best state to find the final best state as a result. Just like you find the less steep area in climbing a mountain for ease. According to eduba.com, in technical term, if we talk about any programming language without any algorithm, it's not possible to write any effective logic. Before writing any logic in a problem language, here are the things we should consider. The correctness of the program. In any conditions, your output should be considered before applying any algorithm. Make sure your output is cent% correct, otherwise, there is no meaning of algorithm or your program. Time. Time is very important everywhere. You must be aware of how much time your algorithm is taking to complete the work. Complexity. How complicated is your algorithm in terms of logic? The time that is taken, and how much memory is used to complete the work? Here are the 5 characteristics of a good algorithm. Finiteness. Any algorithm should complete at one particular time, and that is very important for any algorithm. Otherwise, your algorithm will go infinite state and it will not complete ever. Definiteness. Each algorithm should be clear and unambiguous. Effectiveness. Each line of an algorithm should be essential. We should try to write in a simple way so it could be basic. Input. Every algorithm should take input. It can be 0 or 1 or more, according to the conditions user can use. Output. For any work, some output should come. This is a must. Otherwise, there is no meaning to the work. In the same way, each algorithm should generate one or more output. Here are situations where algorithm has been used. If you are searching for a basketball shoe on a search engine like Google, next time you will get a similar type of shoe as a suggestion. If you are watching any video on Facebook or YouTube, the recommended videos for you will be the similar to the one that you are watching. In the list of people you may know, all the people in the list are someone you have mutual friends or someone near your location. Here, we are going to discuss to you the various advantages of using algorithms. The algorithms are very easy to understand and can be written in simple language which can be understood by anyone. Every step has its own logical sequence, hence it is easy to debug. Algorithm can be broken down into different pieces, which will be easy to implement practically. Now that we're done with the advantages, we are now going to learn about the disadvantages of using algorithms. It is difficult to convert the complex task into proper algorithms. It's time-consuming process because we need to spend proper time in writing algorithm and later we need to implement it in a programming language. It's complicated to show functionalities for each step of introduction and algorithms, and it's hard to understand each flow in the term for loop and branch.
So to summarize, we learn what is algorithm, the four major stages of algorithm analysis and design, the types and characteristics of algorithm, the application of algorithm, and the advantages and disadvantages of algorithm. That's all for today. Thanks for tuning in. Don't forget to like and subscribe.